theory of relativity, a cornerstone of modern physics, is predominantly associated with Albert Einstein. The development of this theory unfolded in two distinct stages, initially with the establishment of the special theory of relativity in 1905, followed by the introduction of the general theory of relativity in 1915. Special theory of relativity, 1905. At the dawn of the 20th century, while working at the Swiss Patent Office, Einstein ignited a revolution with his work on the special theory of relativity. He shared his pioneering findings in a paper titled, On the Electrodynamics of Moving Bodies, published in 1905. This work introduced two postulates. The laws of physics are consistent in all inertial frames of reference. Essentially, if you're traveling in a vehicle at a constant speed, you cannot detect your own movement without an external point of reference. The speed of light in a vacuum is a constant that remains unaffected by the relative motion of either the observer or the light source. Einstein's theory resolved the inconsistencies between Maxwell's equations, which govern electromagnetism, and the laws of mechanics. It achieved this by introducing substantial alterations to mechanical laws when dealing with velocities approaching the speed of light. This theoretical foundation paved the way for the development of the equation E equals mc squared, which posits the equivalence of matter and energy. General theory of relativity, 1915. A decade after his work on the special theory, Einstein proposed his general theory of relativity in 1915, extending the original theory to encompass phenomena involving acceleration and gravity. In this theory, Einstein put forth the idea that massive bodies distort the fabric of spacetime, leading to the effect we perceive as gravity. This concept was a significant departure from Newton's traditional interpretation of gravity, which depicted it as a force of attraction between objects. Contrarily, Einstein proposed that objects travel along the curvatures in spacetime, redefining gravity not as a force but as a consequence of the curvature of spacetime induced by mass and energy. The general theory of relativity received its first experimental confirmation during the solar eclipse in 1919. Arthur Eddington's observation of starlight being deflected as it passed near the Sun was a key prediction of Einstein's theory, and its verification marked a milestone in the acceptance of the theory. Nonetheless, my research introduces a compelling new perspective. It seems that every mass defect in the universe is transformed into an extraordinarily thin form of matter. Such a process of mass defect is a common occurrence, and cosmic events, such as active stars, supernovas, colliding neutron stars, and merging black holes, all contribute to the creation of this remarkably fine form of matter. As a result, it seems plausible to assume that this type of matter pervades space. This insight could potentially offer more accurate and alternative explanations for various phenomena currently explained by the theories of relativity. I encourage you to review my previous videos that delve into how this fresh perspective can reshape our understanding of the universe. Presently, I am in the process of preparing my research for submission to a peer-reviewed scientific journal.